let's review some college algebra concepts. The first question says f of x is equal to x squared minus 2x minus 3. I ask for a vertex here, x-intercept, y-intercept, axis of symmetry, and then it's nice to have 5 points in total to graph it more accurate, and then finding the domain and range at the end. To find the vertex, if you remember y equal to x squared, ax squared plus bx plus c, then as a result, x is equal to negative b over 2a. That's the x of the vertex. Whatever value you find here, you put it back to x and you find y, and that would give you the y of the vertex. So in this case, a is 1, because there is nothing multiplied by x squared, b is negative 2, and c is negative 3. So you find x is equal to negative b, negation of negative 2 is positive 2, over 2a, so that's 1. And then y is equal to 1 squared minus 2 times 1 minus 3. And that would be equal to negative 4. So right here, we have the vertex. So you can start graphing as soon as you have points. And then I want you to note that this graph will be upward because the coefficient of x squared is 1 and it's positive. So the point 1, negative 4 is right here. Okay. And then finding x-intercept and y-intercept. Y-intercept happens when x is 0. So that would be y equal to 0 minus 3. And that's negative 3. So y equal to negative 3. So that would be this point. So since this is going to be the axis of symmetry, we said always the line that is passing through the x of the vertex is the axis of symmetry. So if the vertex is 1, negative 4, then x equal to 1 is the axis of symmetry. So then you know that you will have a point right here that is symmetric to this one. And that point should be, if this is 1, this is 0, this should be 2, negative 3. Okay, next you want to find x-intercept. X-intercept happens when y is 0. You have x squared minus 2x minus 3. If you want to factor this one, two numbers that they multiply to negative 3 and add up to negative 2, it's probably negative 3 and positive 1. Putting it equal to 0, you would get x equal to 3 or x equal to negative 1. So x equal to negative 1 is here. And it makes sense that 3 to be the other point if you see that these 2 points are symmetric with respect to the line of axis of symmetry. Here is, you connect the points. And then it's asking for, you have total of 5 points here. 1, 2, 3, 4, 5. And then it's asking for domain. Domain of parabolas or quadratic equations are all real numbers, so negative infinity to positive infinity. And the range is starting from negative 4 because you don't have anything below negative 4, so it's negative 4 going all the way to positive infinity. Okay, that's the complete work and complete graph. Next question. It's graph of f of x equal to x plus 7 over 2 minus x. So this is a rational function, graphing rational function. We need to find horizontal asymptote, vertical asymptote, x-intercept, y-intercept, and domain and range. So in order to find the vertical asymptote, you just let the denominator equal to 0. So 2 minus x equal to 0, x equal to 2. That's going to be your vertical asymptote. So that's 1, 2. That is x equal y equal to 2. So that's a vertical asymptote. Horizontal asymptote is you have x plus 7. The leading coefficient on top is x. You have 2 minus x. The leading coefficient on the bottom is negative x. We said always the one with the x of the highest power. That's negative 1. So y equal to negative 1 is the horizontal asymptote. And that would be here. So next, you want to find x-intercept. That happens when y is 0. And then y-intercept happens when x is 0. So when y is 0, you have 0 equal to x plus 7 over 2 minus x. So as a result, we don't care about the denominator. When we are putting it equal to 0, we put the numerator equal to 0. Okay, x equal to negative 7. You make sure that negative 7 is not making the denominator 0, which is not in this case. So that's 1, 2, 3, 4, 5, 6, 7. So that's the x-intercept. And then y-intercept is when x is 0. When you let x equal to 0, you have 7 over 2 because it's going to be 0 plus 7, 2 minus 0. So that's 3.5. Even if it's decimal, you need to have an idea where to put the point. So that's 3, that's 4, 3.5 is here. Sorry. Oops. So that's y-intercept. So that's 1, 2, 3, 4, 3.5. Okay, for this side of the graph, it seems that it's easier to connect the points because you have both x-intercept and y-intercept on this side. You need total of 5 points. Again, it's approaching the vertical and horizontal asymptote, but it's not crossing them here. So you need to find more points on the other side of the vertical asymptote. So always, if there are vertical asymptote, you need to find points on either side. So x, y, and you have 3, 4, 5. Because this is a point 3, you can just say 3, 4, 5, whatever points you want. So you have 2 points so far, you need 3 more. So that would be 3 plus 7 over 2 minus 3. That is negative 10. Then you have 4 plus 7 over 2 minus 4, negative 5.5. And then 5 plus 7 over 2 minus 5, that is 12 over negative 3, which is negative 4. So you just put the points. So when x is 3, y is negative 10. That would be, let's say, 2, 3, 4, 5, 6, 7, 8, 9, 10. When x is 4, you have 5.5, 1, 2, 3, 4, 5. And then when it's 5, it's negative 4. 1, 2, 3, 4. Okay, and here's the graph of this side. Again, approaching the asymptotes, but it's not crossing. Next, and this is a complete graph. Okay, for domain and range. Domain of this one is everything except what makes a denominator 0. So that's everything except x equal to 2. That would be the same thing as negative infinity to 2 union with 2 to infinity. Range is anything except, as you see here, anything but negative 1. So that's y is not equal to negative 1. Negative infinity to negative 1 union with negative 1 to infinity. Okay, next question. Graph of exponential functions. Labeled horizontal asymptote. X-intercept, y-intercept, and 5 points in total. Horizontal asymptote of the parent function. If the parent function is y equal to 2 to power x, the parent function has a horizontal asymptote of y-intercept, which is, x-intercept, which is y equal to 0. So that is the original horizontal asymptote. But then since you are shifting it 1 down, the new horizontal asymptote is really right here. So, and that's the line y equal to negative 1. So I'm going to start with the horizontal asymptote, and that's y equal to negative 1. X-intercept and y-intercept. X-intercept happens when y is 0. So you would say y equal to 0. That gives me x-intercept. So 0 is equal to negative 2 to power x minus 1. You solve that. You add 1 to both sides. 1 is equal to negative 2 to power x. You divide both sides by negative 1. So negative 1 is equal to 2 to power x. So 2 to no power will be a negative number, so this does not exist. Now you want to find the y-intercept. That happens when x is 0. To find the y-intercept, and that is y equal to negative 2 to power 0 minus 1. So that would be negative 2. Because 2 to power 0 is 1, negative 1 minus 1 is negative 2. So here is the y-intercept. And then I said 5 points in total. You only have 1 point, so you need to come up with 4 more points. X, y. You can pick negative 1, negative 1. You already have 0, 1, 2. To save some time, I plotted the points and calculated them by just putting into my calculator. So you have the horizontal asymptote, you have 5 points here, and you have the graph. Domain and range. For every graph, you need to be able to find the domain and range. Domain is all real number. You don't have any restriction for input of exponential functions. But for the output, if you see you don't have anything above negative 1, even negative 1 itself is not there. So it's going to be negative 1 exclusive of negative 1 itself, and negative infinity. So you start from negative infinity and cut it at negative 1. Okay. So that's the graph of y equal to negative 2 to power x minus 1. We'll continue to the second video for the next few questions.